Page 97. 97. And question number 5 said, how many electrons will be in the valence shell of non-hydrogen atoms when they make covalent bonds? And the answer should have been 8. How many electrons will be in the valence shell of hydrogen atoms when they make a covalent bond? 2. And let's just check and make sure you drew the Lewis dot structure of I2 correctly. We have I, and I is in group 17. So it has 1, 2, 3, 4, 5, 6, 7 electrons, although I actually prefer to put the single electron over on the right so it's beside the other atom. And we have 1, 2, 3, 4, 5, 6, 7 electrons. 7 is not stable. We need to have 8. So we're going to have I, 1, 2, 3, 4, 5, 6, 7, 8, and I, 1, 2, 3, 4, 5, 6, 7, 8. So the I on the left has 8 electrons. The I on the right has 8 electrons. So everyone has, what do we call that? We call it a complete what? Octet. Okay, so we have a complete octet, and we could, if we wished, redraw that. How could we redraw the bond instead? We could make a line. Okay? How many lone pairs does each I atom have?
3.
It has 3. We've got 1, 2, 3 lone pairs. How many bonding pairs does each I have? They each have 1 because that bonding pair belongs to both of them. Okay, so each bonding pair each I atom has 1 bonding pair. That makes for a total of 4 pairs of electrons, which equals how many? 8. And that's the object that we're trying to get to each time. All right, I would like you guys to try numbers 7 and 8 right now. Okay, 7 and 8 on page 98. Hi. 98. Yes, I just put it down. There you go.
Thank you.
Hi.
May I have the average atomic?
Redo?
Yep. Thank you.
Yeah, and if anyone wants to redo their quiz right now, or if they want to write their quiz right now,
Thank you.
you can do so while we are working on page 98. Yes, sorry about that. Yeah, you wanted the average atomic mass? Yeah.
No, the first one.
The first one, the protons, neutrons,
Yeah,
electrons? Yes. There you go. There's 2 H's. So now, first of all, H is all number 1. All right, let's start. So, we're talking about this. Oh, that's not probably not one. This one not with that one. Yeah. Then the low pair for protons will be lost. Well, you're going to draw it, and then you'll see how many ones. So even if you don't draw them like up and down, Yeah. So you have to give it and because hydrogen is only possible. But like this. And it wants to have somebody, the pole wants to have hydrogen is an exception with bonds that work up to nitrogen bond in order to start with the one. If hydrogen starts yeah. Yeah, once you've done number 7, you can read number 8. If you finish those, you can just keep going. Yes, yes. Those are volunteers.
Good actually.
That's one volunteer. That's 2 volunteers. Yeah. Or 31. School up. And that one. Okay, so first of all, what we're gonna do is when we go sulfur, remember we don't want them to pair up unless they have to go 3, 4, 5, 6, doesn't it? Yes, and that's why we have to do it that way, because that way it will make some kind of sense. Yeah. Yeah. Yes, for sure. Yeah. These are covalent, so they're not going to be made like that. They're going to bond like that or like that. Because they're going to share electrons because it's 2 non-metals. Okay. So for this, so what you'll see is first of all, sulfur, it's not 2, 2, 2, it's 2, 2, 1, 1. See how there is an unpaired electron here and an unpaired electron there. So those hydrogens pair up there.
How many lines? 1, 2,
there.
You take 1 hydrogen? How many lines? 3, right?
Yes, and then you should replace those with lines if you wanted to.
How many bonds do you think we go? Oxygen forms, so that's the oxygen, right? So if we look at the periodic table. Yeah, okay. So here's the oxygen group. And sulfur, this is oxygen group, how many bonds? Two bonds, yeah. Yep. Lone pairs are the ones that are not bonded. Okay. Yeah. Yeah. That's a pair, one, pair, two pairs. Bonding pairs, that means one pair. This hydrogen has only one pair. That counts for. There's this, each hydrogen has one. Each hydrogen has one. Yeah.
Oh, do we just do?
You can just keep going on page 99, okay? Oh, that would be what they're forming on the start. These are nobody's empty. And nobody. They're all just. Okay, because that's where they're really what must be. So they go to the electrician, but it's not very. Okay. On this. There is, you can get one. Well, should we finish page 98? Go on to page 99. Yes. Okay, so if we look at this one, right, we have. For her, you need from the line. So they were put on the screw line. Something is more to make care of these lines when they are good lines. Yeah, how many unpaired left are is that? Like seven, when you open the line.
How would I like? How would I create that? Because like each one is now like. Whatever was currently 97.
Well, they have seven, going to group 17. Oh. Does that solve your problem? Yeah, okay, okay, cool.
Wow.
So, how many people? Bonding there, so bonding. Two electrons go one pair. And okay, so now we like. So if we're going to be on.
I'm gonna remember that.
Well, so I'm gonna go through the first one, just in case, I've hit a lot of you with it, but I haven't hit everybody. So if you have questions about it, this will be a good time to do it. First of all, I want to show you things that are going to make it hard to draw the structure. If you draw sulfur like this, you're going to get stuck because you're going to say, I got a hydrogen and I got a hydrogen, and what do I do with those electrons? It gets complicated. Yes, you can't really see where they go. And that's because we should not be drawing our pairs together unless they have to be. So instead of that, we should have one here and one here. Another thing I wanted to point out is that hydrogen is in group 1. So how many electrons does it have? It has just 1 electron. I know I've said hydrogen has 2 electrons, but what I'm saying is that hydrogen needs to have 2 electrons when it is done bonding, okay? When hydrogen is finished bonding, it needs to have 2 electrons. Okay, so if I've got a hydrogen here, and I've got a hydrogen here, then hydrogen can share with sulfur here, and this hydrogen can share with sulfur there. So we have sulfur then. And we have hydrogen here, and we have hydrogen here. Does it matter if the hydrogens go on the side and the bottom, or would it be okay if I drew the hydrogens one on each side? Would that be okay? Is this an okay structure? Yes, that's fine. Is this an okay structure? Yes, that's fine, okay? Then we're going to redraw that with lines. Okay, and now we look for lone pairs. Now, a lone pair looks like this, or it looks like this. That is one lone pair, 2 electrons. That's not shared by the 2, okay? So how many lone pairs does a hydrogen atom have? None. Okay, there's no lone pairs on hydrogen. How many bonding pairs does a hydrogen have? Now, a bonding pair is a pair that occurs in between 2 atoms. So the bonding pair is between 2 atoms. And when we redraw them as lines, the bonding pairs are the lines. That's why I kind of like to draw them as lines, because that's what they look like. How many bonding pairs does each hydrogen have? Just 1. How many lone pairs on sulfur? Well, here's sulfur, and it's got 1 lone pair, 2 lone pairs. How many bonding pairs on sulfur? So you need to say how many lines are attached to sulfur, and we can show that right here. We've got 2. So we have 2 bonding pairs. Now, this last question is a little complicated. Yes? Why is what? C. Why is C 1? Because if we look, it's asking for each hydrogen. So one individual hydrogen has one bonding pair. The other hydrogen has one bonding pair. So we're asking for each individual one. Does that make sense? Cool. Now, the oxygen group, if we go to our data pages and we look at oxygen, we can call it the oxygen group, but we could also call it group 16. If I get rid of this, this will be helpful. Okay. Now, everybody in group 16 has 6 valence electrons. So let's go back here. So if I have sulfur, 1, 2, 3, 4, 5, 6. If you look here, this sulfur needs another atom to bond with it in order to get a pair. So anytime you see a singleton electron, so single electrons need to bond to become a pair. The goal, of course, is to have how many pairs? 4 pairs. Which is 8 electrons, which is an octet. So if we look at any element in group 16, we could look at oxygen. 1, 2, 3, 4, 5, 6. We have an unpaired electron here, and we have an unpaired electron here. 2 unpaired electrons. Therefore, it will usually form how many bonds? 2 bonds. Does that make sense? Because it needs, anytime you have an unpaired electron, it needs to form a bond. So if you have 2 unpaired electrons, you'll need to form 2 bonds. If you have 3 unpaired electrons, you will need to form 3 bonds. If you have 1 unpaired electron, you will need to form 1 bond. And in fact, we can go back to the 3.0s. Let's see if it's okay, so let's go actually to page 8. Okay, let's go to page 8. Now there's some extra stuff on here that we're going to ignore for now. Okay? So we're going to ignore the thing that says incomplete octets because we're going to come to that either late today or tomorrow. But for now, we're going to go to page 8 and we're going to say, here is hydrogen. How many unpaired electrons? Oh my God, look at the hydrogen. Tell your partner, How many unpaired electrons? Get off your phone if you're on your phone. We have one unpaired electron. One unpaired electron. Therefore, how many bonds will we form? One bond. Okay, so hydrogen only ever forms one bond. So never try and put hydrogen in the middle of a structure. Would it make sense to say, oh, I've got NH3. Let's say I have NH3. Would it make sense to go H, N, H, H? Is that a structure that makes sense? No, because this hydrogen would have two bonds, and this hydrogen would have two bonds. Does that make sense? So we don't want a structure like that because hydrogen can only ever have one bond. Okay, so that's when you need to start thinking about that, because we're going to draw what we call the skeleton structure, which is where you place the atoms where they go. Okay, and you need to say hydrogen always needs to go on the end or on the outside of the molecule, because it cannot bond to two things or more. It can only bond to one thing. Fluorine, chlorine, bromine, iodine, they all look like this. So for example, we might have fluorine. One, two, three, four, five, six, seven. How many unpaired electrons? One unpaired electron. Therefore, how many bonds will fluorine form?
One.
It can form only one bond. Now, if we go over to the left here, I'll come back to that in a minute if you missed it. But if you look, it says fluorine. How many bonds can fluorine form? Only ever one bond. Yes? Chlorine, bromine, iodine. Usually only one bond. Yes, because they all have that one unpaired electron. Now, over here, this is going to be an enriched thing that we get to maybe at the end. Some of you will get to this. There are complicated things that can happen that can make the bigger halogens sometimes have more bonds. Fluorine can only have one ever. For most of you, chlorine can only ever have one bond. Okay, but occasionally we can have chlorine with more than one bond. Okay, but that's for enriched. For a regular, you just need to know this part. Okay? Regular, enriched. Okay? So hydrogen, only one bond. Halogens, only one bond. Carbon, let's take a look at carbon over here. How many unpaired electrons? 4 unpaired electrons. And therefore, how many bonds? Therefore, 4 bonds. And you'll notice over on the left, it says carbon almost always will have 4 bonds and 0 lone pairs. So if we look at all these structures here, we can see carbon has 1, 2, 3, 4 bonds. We're going to start getting fancy with bonds later on. And you can see we have 1 bond, 2 bonds, 3 bonds, 4 bonds. We can put more than 1 bond in between atoms, which we'll learn about maybe later this lesson. Okay. How many bonds does this carbon have? 1, 2, 3, 4. How about this carbon here? 1, 2, and then 3, 4. How many in this carbon here? 1, 2, 3, 4. So almost always 4 bonds. There will be a few situations where it only has 3 bonds, but we'll learn how to do those ones later. We'll learn this. We'll learn the exceptions later. How many valence electrons does oxygen have? How many valence electrons? It has 6 valence electrons. So how many unpaired electrons would it have? It would have 2 unpaired electrons. Therefore, how many bonds will it tend to make? 2 bonds. Okay, so generally, here's an oxygen, 1 bond, 2 bonds. Oxygen, 1 bond, 2 bonds. Oxygen, sometimes it has 1 bond, but usually that's in an ion. Because what an ion will do is it'll throw an extra electron in there. So instead of having two unpaired electrons, you'll only have 1 unpaired electrons. But we'll learn how to do this later. Okay, but usually 2. And occasionally, oh my gosh, it can have 1, 2, 3. But again, we'll learn this later. Basically, it's kind of like, oh, I have no choice. Can you imagine if I have an oxygen and 3 hydrogens, who has to go in the middle? If you have fallen asleep, now is a good time to wake up. Because if you have an oxygen and you have 3 hydrogens, how many bonds can hydrogen ever form? 1. Who has to go in the middle? Oxygen. Okay? And do you know what you notice here? We have a positive charge. That means that someone somewhere has lost an electron. So instead of having 2 unpaired electrons, it will have 3 unpaired electrons, okay? But there is a method for doing the complicated ones that I will teach you later. So you don't have to worry about it for now. For now, with the simple structures, you say oxygen. Oxygen has 2 unpaired electrons, therefore it will form 2 bonds. And we'll worry about the other things later. Nitrogen. How many bonds should nitrogen form, given that it has 5 valence electrons? 3 bonds. And you can see 1, 2, 3. That's a triple bond. 1, 2, 3. Every once in a while, though, you can have 1, 2, 3, 4 bonds, and you'll notice that that's an ion, so we've mucked up the number of electrons again. Here we have 1, 2, 3, 4 bonds. Again, that's an ion, so we've mucked up the electrons again. But don't worry, ions will have a different method for finding them, okay? We can ignore this last bit, just cross that right out, okay? And we're not going to worry about the expanded octets. Those are going to be for enriched stuff later in our lives. Okay. Okay. So I'm going to leave 99 for you to finish at home, and we're going to do a very quick intro to double bonds and triple bonds. Today will be frustrating with these, okay? So just bear in mind that the only reason I show you this method is so that you say, when I go to teach you the other method next day, oh, I see why you teach us that other method, because trying to cram them together just in my head and make it work is complicated and hard, okay? So we are on page 100. Multiple covalent, yeah. Let's take a look at oxygen here. And if we have O2, we know that O2 is a molecule, yes? O2 is a molecule. But if we take and we form one bond by sharing those two electrons, how many electrons does the oxygen on the left have? 1, 2, 3, 4, 5, 6, 7. Uh-oh. Is that a happy oxygen? No. And this guy over here, same thing. It's just got 7 electrons. So these two oxygens are not yet satisfied. What if we rearrange where the electrons are? What if we just move them around? Okay, so what we've done is we've taken 2 electrons, we've taken the electron from over on this side, and we've moved it over here. Well, that makes this one okay. I got 1, 2, 3, 4, 5, 6, 7, 8. So this one's happy. But this oxygen on the right, how many electrons does it have? Count them. Tell your partner, how many electrons in the oxygen on the right? 6. Is that happy? No. So we cannot satisfy oxygens by having one bond. How can we fix this? We can have... Do you have a question? You good? We count the ones in the middle for both of them. Okay, so you would say this oxygen over here has 8, and this oxygen over here has 6. Does that make sense? Yeah. Good question. But what if instead of sharing only one pair of electrons, what if we shared 2 pairs of electrons? So what if we shared this pair here and we shared these 2 electrons here? Yes? Look at that. Now let's count up all the electrons on the left-hand oxygen. 1, 2, 3, 4, 5, 6. But in the middle, we don't have just 2. We have 7, 8. We have 4 in between the 2 atoms. So that gives us 8 electrons. And on the right-hand side, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Is everybody happy now? Yes. So we take a look at this and we go, oh, okay, that's great. And we can redraw it with, instead of having those 2 pairs of electrons drawn as dots or X's, we can draw them as 2 lines, okay? So 2 lines. One line is 2 electrons, the other line is 2 electrons. So how many electrons altogether? 4 electrons. is good. Okay, and if we count up the total number of electrons, we have 1, 2, 3, 4. This bond is 5, 6. This bond is 7, 8, 9, 10, 11, 12 electrons. That's how many electrons we started with, right? Over here we had 6 electrons and 6 electrons. So we don't have extra electrons coming in from somewhere. You can't just throw in extra electrons to make your problem go away. You can't take away electrons to make a problem go away. You have to say, oxygen starts with 6, the other oxygen starts with 6, so my final structure has to contain 6 plus 6 is 12. Does that make sense? If you've only got 12 electrons to work with, you have to have 12 at the finish. Okay? So oxygen has formed 2 bonds. Remember, oxygen group has a tendency to form 2 bonds, so this is actually really good, right? We're like, hey, it's got 2 bonds. That's great. That's what we would expect. And just down here, it says what I was just talking about. We do not add electrons, right? We don't just say, oh, 12 doesn't work. Why don't I have 14? Because you don't have 14. 2 oxygens will not give you 14 electrons. Each one only has 6. You can only get 12 electrons out of 2 oxygens. Now, we also know that nitrogen is a diatomic. Yes? Nitrogen, diatomic. So here's our nitrogen. Each nitrogen starts with 1, 2, 3, 4, 5 electrons. So our final structure should have how many electrons? 5 electrons and 5 electrons gives 10 electrons. So we're only allowed to have 10 electrons in our final structure. Does forming 1 bond work to satisfy everybody? No. Can we satisfy nitrogen by sharing 2 pairs of electrons? No. Over here, we would have 1, 2, 3, 4, 5, 6, 7. So this guy has 7 and this guy has 7, and everybody is still not happy. How could we fix it? We could share 3 pairs, 6 electrons. Okay. Oh, look at that. So now the nitrogen on the left has 1, 2, 3, 4, 5, 6, 7. Oh, good. 8 electrons. And this guy over here has 8 electrons. We also have to check our structure and make sure we didn't throw in extra electrons to make our problem go away. Remember, we had 5 and 5. So let's count them up in this structure here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in total. So that is exactly what we needed. And guess what? Do you remember nitrogen has 3 unpaired electrons? How many bonds does it tend to form? 3. What did it form? 1, 2, 3. Oh, beautiful. Yes? Okay. Now, carbon dioxide, this one is doable. HCN, you're going to put C in the middle. This one is doable. Carbon monoxide is kind of doable. Now, the thing to remember is that the compound violates the tendency of carbon to have 4 bonds. So you can expect this to be an exception to the 4 bonds and an exception to oxygen having 2 bonds. So don't try and make it happen. But if you get stuck on carbon monoxide and you cannot make it happen, that's okay. And then finally, we have ethene, which is going to be more of a challenge. Okay. And then finally, this one is super hard. It will become easy with the method we learn next day. But if you can manage to make it happen just with the regular method, then you are golden. Ha. So really what I expect you to be able to do is to do number 1, do number 2, and then with the rest, just do the best you can. Okay? If you cannot get them, that's okay. So number 3, 4, and 5, it's okay if you don't get them. So your homework then is to finish page 98 to 99 and to do page 102, numbers 1 and 2, and then try, you don't have to succeed, page 102, number 3 and 4. And if you want to challenge yourself, you can try page 102, number 5. Okay, but don't beat yourself up if you can't do them, because there's a much better way of doing them that makes it much easier. Okay? Thank you. I'm just gonna give them all. Yeah. We have long blocks next Monday, Tuesday, I believe. Let me double check. Yeah, long blocks Monday, Tuesday. So I will see you guys on next Tuesday. Or day in the morning, all morning. What? Wednesday is what? Oh, what? Wednesday's normal. Yeah, in our old calendar, they had 4 long days of long blocks, but now they've gone down to only 2 because they don't need all 4. Yes. Oh, yeah, it's gone into, so it comes back. Yeah. Okay, so part of the middle. I will click on that, but I cannot be at this.
This is ridiculous. I really
Now, you know what it's here say, carbon needs to go around electron. Right now, it has singletons, 4 singletons on the lines. If I pair up like this, I have to have to pair instead. If I pair up like this, that should have pair instead. That was it. What that'll give us is infinite That makes sense.
They come to, they so have.
Four electrons in it. Yeah, and this one has a oxygen over here.
I don't understand what I say.
And no, they're here. They're here. And we found out that you say that oxygen has 4 8 electrons. This carbon. And this oxygen has how many electrons? 8. Everybody has 8, but we still have only 2 plus 6 plus 4. 16.
No, I think it's great.
Out of all the electrons. 16. Yeah. So that structure works. Everybody has 8, good, but we've got enough. So we're good.
It is, but it's not enough.
And you can count your electrons the same way here. You can say, okay, this oxygen over here has 4 line right there. So carbon has 2 resources. So try. Yeah, so you use carbon in the middle with the nitrogen on the other side. Yeah. Okay, so carbon. And we have oxygen.
That makes so much sense.
That would still be about. Another one. Okay, so say up here. This guy is on here. You know, there's another these guys. Yeah. Then draw it. Burden. And then in between, you have 1, 2, 3, 4. 4. Yeah. And how many things are in 4? 4. And now we're going to do the intros on this. And then you can count them up. So what you do is you make oxygen owns all the electrons that are around it. You just stop right there. But this carbon owns all the electrons that are there.
Oh, I know you.
8, right?
Oh,
Over
yeah,
there,
yeah.
and then 4 down here. Got it. Okay, and then this oxygen owns 8. Everybody owns 8 electrons. That's what we want. Yes. And we need, yeah, and then we need to check and we need to say we started with 4. And then each oxygen had 6. Yeah. So that gave us.
Yeah.
Yeah, yeah. So that's a good structure. Oh, and then you just replace those with lines.
Yeah, I love that. Get extra. So.
Yes, I'm sure. Now, you can just do this in there. You can leave the soils there. So they both end up between the two. Yeah. Hello. Yes, you did. Yes. Yeah. Okay.
I was thinking something.
I know, right? You're gonna be so happy that you learn how to do it the other way, because then there's like, it's so much less complicated. It's not 100% a one go, but it's just fearful, like there's less chance of making mistakes and one something.
Oh, that's.
Okay, so we're fine. Carbon still remains this one with someone. This oxygen. This oxygen. Here. That was our unfair welcome, yes. Okay, so it's got one unfair welcome. Oh, God, I think so. They will also. And then you want oxygen.
How long did it take you? Oh my God.
Right? So that's why I put this one in here, because this is going to when you start using the power method. Okay, because you're gonna say, okay, well, this one's nice, but what if I did?
That was last. Because merger problem entered.
Oh, actually.
Make sure it's something.
Okay, so what if we took this one here, here?
Yeah.
Actually, yeah. What if we stuck it here? Okay, so we move that here over here. And now we have one here, right? So we swap places. And now these two and go together. So now you have carbon with 3 bonds. 2, 3. There, and an oxygen and a there. Yes. Okay, so you can never have electrons connected. So now the first thing is, how many oxygens do we have? There's 2 of them. And the oxygen is in group 16, so how many electrons does it have? 6. So we have carbon, test 4. So we have oxygen to 6.
Added to my here.
5, 6. I'm gonna put another oxygen down here, which has 1, 2, 3, 4, 5, 6.
Oh.
Yes? Now, this electron needs to partner up with somebody from up here. Okay, so maybe these two partner up.
But I don't think that's how.
And maybe these two partner up. Yeah? And then those two. And those two. Yeah? So we're gonna have carbon. Those ones. I'm sorry.
I'll talk about it and.
Oxygen, because that's not electron, there's not a center. Go along there at the lone pair. Yeah. And now we have this oxygen here, we've got 2 electrons, 2 electrons. And we have the oxygen and the members. I mean, and then you look and you say, how many electrons does oxygen have? 2, 4, 6, 8. How many does carbon have attached to it? 2 in each bond. 2 in this bond. 4, 6, 8. And then how many in that oxygen? 2, 4, and then these 2 makes 6. So everybody has 8. If we count up all the electrons, we have 2, 4, 6, 8, 10, 12, 14, 16. How many did we start with? Carbon has 4. Oxygen has 6. Oxygen has 10. So you have 16 here, you have 16 here, that's good.
That's probably what I could.
Yes, that's good. Looks good, 4 looks good, and I believe that's yes. Yes. Yeah. That looks beautiful. Very nice.
I think every should be. Oh, and I lost it.
Or your constant each has 3, 4. No, 6. I have another one down here. 1, 2, 3, 4, 5, 6. Now, everybody needs to partner up to make it. Okay, everybody's unpaired right now. So you see how this one is unpaired and that one's unpaired? No! Those two pair up together and make a bond. That one's unpaired, that one's unpaired. Those two pair up and make a bond. Here, this guy's unpaired. Pair up and make a bond. This guy's unpaired. So now we're going to In between the carbon atoms, you have a both oral elements. Yeah, I was going